Alright, so this would be the second video that we're going to work on. This is a worksheet that you'll work on tomorrow in class. Just thought I'd give you a few examples. First of all, thought maybe we could talk about sketching a vector that goes from point A to point B and then changing it to its component form. Okay, that's a little bit of review. So suppose I give you the coordinate 7, 3 and -4, -5, and I ask you to sketch that vector. Well, 2, 3, 4, 5, 6, 7, 1, 2, 3. So there's the initial point, and then 1, 2, 3, 4, 1, 2, 3, 4, 5. There is the terminal point. So here's the vector. So we had initial point A, terminal point B, and we're asking for the component form. And that's where we're listing it like a coordinate. Now remember, one way I said we could do it visually is to imagine that this becomes the new origin. And then we could think in terms of, okay, you're going left 7 and then a 4 more, so that's left 11. And you're going down 3 and then down 5 more, down 8. So there's the component form for that particular vector. As some of you might have realized, you could also do B minus A, right? So you got -4 minus 7 and -5 minus 3. It arrives at the same component form, okay, telling you which way to go, left and down, to get to from, as if the origin was right there. Now if I give it to you in component form, I may ask you to sketch the vector and find its polar form. Now remember that the polar form, that's with the radius and the angle measurement, and the other term that we have for radius is magnitude, and the other term for the angle is the direction. Now I guess the only difference is that direction in terms of a vector is from 0 to the right. So we'll see what we need to do here, but let's sketch it first. We got 1, 2, 3, 4, 5, 1, 2. So right there is our vector. We've talked about how you can look at it as a right triangle. Keep in mind, we need to find this angle all the way around there. So folks, that's an angle that's it's pretty big. All right, there's 270, so it's going to be larger than 270 degrees and smaller than 360. Now I know that we're going to find this angle inside the triangle right there. Here, let me zoom in on that part. But that angle that we're going to find out, called x, is not the one we're looking for, to quote the stormtroopers. That is not the angle we're looking for. Anyway, let's find that magnitude first, also the radius. We know that this is 5 and this is 2. So we've got the square root of 5 squared plus 2 squared. Square root of 25 plus 4, or the square root of 29. That's the radius. Then, as we've done in class, the tangent of x is equal to 2 over 5. X would then be the inverse tangent of 2 over 5. I'm going to go grab my hand. Oh, I've got a handy dandy machine right here. Invert the tangent of 2/5. We get 21.8 degrees. Now that's x, right? That's not theta. Theta is the angle measurement I'm looking for. Theta, we said, was bigger than 270 degrees. So in other words, I'm going to take this 360 and I'm going to come backwards 21.8. So 360 minus 21.8 gives me 338.2. So that's my coordinate, square root 29, comma, 338.2 degrees. Magnitude, direction goes with the idea of a polar coordinate. We can also give them to you in polar form and then ask you to sketch them. Suppose I said 10, comma, 75 degrees. Let's go 175 degrees, just for fun. Okay, so we spin around, like here's 0, 90, 180. So you can tell I'm going to be pointing more towards this area over here, because 175 degrees. And then I'm moving out away from the origin 10 units. So there's my 175 degree angle, and then 10 units out. Okay, and I may ask you for the component form. Well, in this case, keep in mind you have this small triangle that you're trying to use. And you're trying to find x, and you're trying to find y. The picture helps me know, when I look at this, that x is a negative because it goes to the left. And the picture helps me also know that y is positive because it goes up. Now, this angle right in here, we'll call it z. How much is that angle? That's a 5-degree angle, right? I guess I didn't really need to name it because I already knew what it was. So that was pretty much a waste of time. So we're looking for the adjacent side. We have the hypotenuse, so that sounds like cosine. So the cosine of 5 degrees is the adjacent side divided by the hypotenuse. Now remember, that's a proportion. All we're doing is solving a proportion by cross multiplying. In this case, 10 cosine 5. 9.96. Then we can also use the sine, right? Opposite over hypotenuse. The sine of 5 degrees equals the opposite over the hypotenuse. And of course, that's a proportion. We can also solve that. And when we do that, 10 sine 5, we get 0.87. What is, sine 5 times 10. Okay, 0.871. Alright, that makes sense. So the component form 9.96, comma, 0.87. There's my component form. Am I right? Because this is positive and this is positive. Oh no, I'm not right. Because we said that the x, because it's in quadrant 2, the x had to be negative. So just because I used my cosine function and I was able to solve that through cross multiplication, I still have to think about the sign to get the correct answer. So that it's really important that we do that picture. And we're going to work on some problems in class. The polar form of the plane's flight is 3,000 miles and 80 degrees. How far north did the flight go? Did the flight go east or west? Those are some questions you have to be able to think through, and we're going to talk about more in class, okay? We'll practice those in class. So there are some story problems we're going to work on. Okay, we'll see you in class.